This video will cover the first part of zeros of polynomials, actually how to find zeros of polynomials, and on your table of contents is listed as item number 8, which is zero stuff. And so we're going to call it zero stuff. That was Taylor's idea. She came here before class and she asked me, Miss, are we going to do zero stuff? And I said, yes, we're going to do zero stuff because it's all related to zeros. So we're going to find the zeros, okay? So we're going to use two techniques right now. One of them will be factoring, and that's why I made you copy all those notes so that you could kind of refresh your mind on that, okay? But however, if you have a question, you can still ask. So what I'm going to do here, I have a sum of cubes. So I'm going to factor a sum of cubes. And so here on the dry erase board, I have the formula for it. However, I'm going to write it down here. So if you have something like a to the third power plus b to the third power, you could factor it as the product of a binomial and a trinomial, where the binomial will be the cube root of this term, that's a, the cube root of that term, that's b, and we add those two terms. And then the trinomial is going to be this first term squared. Now this second term squared also. And the term in the middle of the trinomial will be the product of the first times the second. So what is a times b? AB. And here the catch is that if we start with a sum of cubes, the sign here must be negative. Okay? So now let's try to factor that sum of cubes the same way. And actually, before I move any further, I want to explain something. We need to find the complex roots. And when we say complex, I want you to keep in mind that complex is the big set which divides into real and imaginary. Imaginary roots are the ones that contain I. And so those, you cannot see them on the x-axis, right? But we'll worry about those when we graph them. Now, real can also be divided into two subsets. One of those is rational. And the other one will be what?
Irrational.
Irrational. So what are rational numbers, guys?
1, 2.
1, 2, yes.
1/2.
How about 1/2? Yes.
1
How about 0.3333?
Sure. Yeah.
Yes, it is.
Yep.
Because as long as you could turn it into a fraction, and that one is exactly 1/3. As long as you could turn it into a fraction, which is the ratio of two integers, then yes, it is a rational number. How about 0.25? Will that be a rational number?
Yes.
Yes, because we have 25 hundredths, right? Or we reduce to 1/4. So yes, those are rational numbers. Irrational will be something like the square root of 2, the square root of 3, or pi, or
Like
e.
numbers?
Rational includes all integers and all fractions. All integers because every integer has a denominator of 1. And positive, negative as well. All right, so we're going back to the problem. Let's go ahead and factor it now as a sum of cubes. And so the first binomial, or the first factor, will be the cube root of x cubed. That will be x. The cube root of 8, what would that be? 2. We have a sum of cubes, so this binomial will have also a sum of the two terms. Now for the trinomial, we're going to take the x, this term, and square it. So x squared. Then we take this term, the 2, and square it. What is 2 squared? No, not. I'm talking about the last one. So 2 squared is 4.
4.
And the one in the middle will be the product. So 2x. Positive or negative?
Negative.
Negative. Okay. Now after we do that, we're going to do this thing called the zero factor property. So we're going to use the zero factor property to find the zeros. So what that says is that you take each factor individually and you equal it to 0. So one factor is the binomial, the other factor is a trinomial. So let's work with the easiest, which is the binomial, of course. And what we need to do here is solve for x. So I can take this positive 2 across to the other side. The 2 is adding, so if I take it across, the inverse operation will be subtracting. So we get that x equals -2. That will be our first 0. Not just our first 0, but also we could tell that it is a real number, right? It doesn't contain I. And would you guys say it's rational or irrational?
Rational.
Rational. Very nice. Okay, now the next side, I could tell you that right now that we're not going to be able to factor it, okay? But I'll show you quickly. If I was trying to factor it into two binomials, it will be x, x. The sign is positive, that means both signs inside the binomials will be the same. However, this one is negative, so that means both signs will be negative. If I use negative, negative here, and then I have factors of 4, it could be 1 and 4 or 2 and 2. But they're all negative, so is there one combination that will give me the -2 coefficient from here?
No.
No. So that tells me this is not factorable, so if it's not factorable, we could use other resources such as completing the square or the quadratic formula. So I'm going to use the quadratic formula here, and before I do that, I'm going to write down the coefficients. So the coefficient of x squared is that number, is a 1. So A equals 1. B is -2, and C is 4. And I'm going to tell you one thing I really hate when students do. So don't do it. I don't like it when they say A, B, C. Why? Because they overlook negative signs. And even if you say, it's not going to happen to me, I know it will. There's like a 99.9 chance you will make that mistake. All right. Anyways, I'm going to go ahead and start substituting here for the quadratic formula. And so that is -b plus minus the square root of b squared minus 4ac over 2a. And yes, we are going to solve it by hand. Because can you use a calculator on the TSI? No. All right. It's not a big deal. So we're going to substitute b, but you notice the formula has a negative in front of it, so that will be negative and then -2. And then we have plus minus square root. We need b squared, so that will be -2 inside parentheses, and then the square. Minus 4, a is 1, and c is 4. Everything divided by 2 times 1. Now we're going to simplify a little bit here. Negative times negative will be +2. Inside the radical, we have -2 squared is +4. But then here we have -4 times 1 times 4.
-16.
Thank you. -16. And you guys, can you start noticing something?
That it's going to be negative, so...
Negative where? Negative where?
Inside
The
what
what?
is it called? Radical sign?
Radical. Inside the radical. So at this point, we have two plus minus the square root of -12 over 2. So at this point, we know that we're not going to have real zeros coming from there, right? What are we going to have instead?
Imaginary.
Imaginary. So what I'm going to do is factor out the -12 inside the radical. So it will be -1. And then I'm going to pick 2 factors of 12 where one of them is a perfect square. 4 and
3.
4 and 3. Perfect square, so a number that you could take the square root and you get an integer as the answer, as such as 4. So now we have 2 plus minus. The square root of 4 is 2, so that comes out of the radical. The square root of -1 is I, and the square root of 3, that 3 will stay inside. All of that divided by 2. Now, I want you to notice how the 2 on the denominator is going to divide the real part and also the imaginary part. Like that. So what do we get here? 2 divided by 2. Will that be 0? But it cancels.
And it's a 1, okay?
It is a 1. Yes, it is a 1. How about here?
1 imaginary
So we could just say I square root of 3. Now from here, I want you to keep in mind the following. We have 2 zeros coming from there. One is 1 plus I square root of 3, and the other one is 1 minus I square root of 3. We have 2 because they always come in what? What kind of pairs? The plus and minus inside, how do we call them? When they have a different sign inside. Huh? What are you? All right, let me help you guys. Who speaks Spanish here?
Me.
All right. Do you guys know a word for spouse?
Novio.
That's boyfriend.
Oh.
Esposo, yeah. How about cónyuge?
Community.
Cónyuge. Cónyuge? No, you never heard that word? That's like your spouse or like your significant other, your cónyuge.
Conjugate.
So we need, so those numbers are complex conjugates. Like they're married. Yes. So how many zeros do we have in total?
3.
3.
Sorry.
That is, 1 is real and rational, and we have 2
Rational.
imaginary. Not irrational, imaginary. So as long as they have I, that makes it imaginary. Let's move on to the next problem. Yes, we do. All right. What is the degree of this polynomial?
2 to the 4th power.
To the 4th power. And what are those two terms doing to each other?
They're subtracting.
So this is actually a difference of squares. Okay? And I know we have x to the 4th, but if you think about it, we could actually take
X squared.
the square root of x to the 4th, because that will be to the power 4 halves. Why is the 4 halves? Because the little index becomes the denominator of the exponent. And so what is 4 over 2?
X squared.
X squared. So to factor this one right here, we're going to do the product of 2 binomials. So we take the square root of x to the 4th, that will be x squared. That goes here and here. And then we take the square root of 4, which is
2.
And then we make one positive and one negative. Now after this, we're going to use that zero factor property. Zero factor property. So we take each factor and we create 2 equations, solve for x. I'm going to start with the one on the right side because it's a little easier. So in this case, we have the -2. If we take that across, it will become +2. How do we undo a square?
What's that called?
Square root. The square root. So x is equal to the square root of 2, but not only the square root of 2, also the negative square root of 2. So right here we get 2 zeros. We get x is equal to the square root of 2, and x is equal to the negative square root of 2. So also irrational zeros, such as that one, will come in pairs. Now let's move on to the other factor. Well, okay, let's write this down. So far, these 2 are real, and they are irrational, because they have the square root of 2, and the square root of 2 cannot be turned into a fraction. The next factor, we take the +2 across, or you subtract 2, so that becomes -2 on the right side, and then you take the square root to undo the square, and here we will have x is equal to, in this case, if I factor out the -2 as -1 times 2, I could see clearly that I'm going to have I, and then the 2 inside the radical. However, we're missing, what are we missing?
We're missing a factor, another pair.
The plus minus, yes, that will give us the pair, yes. So from here we get 2 more. X is equal to the positive I square root of 2, and x is equal to the negative I square root of 2. So how many zeros do we have in total?
4.
1, 2, 3, 4. Thank you. And these ones, they are imaginary. Okay, so this is the end of the video. So, woo, 1 minute early. Look at that, guys. So don't hurry up and pack and go.